Today we are going to learn AVL tree. What is AVL tree? So full form is Adelson, Wilsky, Landis, and it's based on the balancing factor. Balance factor. So first we will see the balancing factor of AVL tree. Suppose this is the tree is given, and because A doesn't have any child, that's why its balancing factor is 0. In the similar way, D doesn't have any child, so its balancing factor is 0. And C is having one child on left hand side, that's why its balancing factor is +1. And C is having two child on right hand side, that's why its balancing factor is -2. And before that we are going to with G. G is having one child on left hand side, because it is on left hand side, that's why +1 balancing factor. Whenever we are having one child on left hand side, so it will be +1. Whenever we are having child on right hand side, it will be minus. So this is no child, so 0. This is no child, so 0. G is having one child on left hand side, that's why +1. C is having one child on left hand side, +1, and two child, or we can say two level, that's why -2. So total is -1. But whenever we are having 0, +1, -1, then we can say AVL tree is balanced. But whenever we are having more than +1, -1 and 0, or we can say +2, -2, then we can say AVL tree is not balanced. So for balancing the tree, what is required? Rotations are required. So we can say whenever we are inserting anything in the AVL tree, then after insertion we will cross check the balancing factor. That balancing factor are 0, +1 or -1 or not. If they are more than that, like +2, -2, then we have to do rotations. What we have to do? We have to do rotation. So we can say in the case of insertion, whenever after adding any node, the balancing factor is either +2 or -2, then rotations are required. So here 4 kinds of rotations are there: LL, RR, LR and RL. LL and R are known as single rotations, while LR and RL are known as double rotations. Why? We will see here. Because LL and RR we can't break further, but LR and RL we can break further. How we can break? That LR, first we go for RR, after that we will go for LL. First we will go for RR, then we go for LL. Because two rotations are there, so that's why they are known as double rotation. The similar way RL, first we go for LL, then we go for RR. So there are also two rotations, first LL then RR. So that's why these are known as double rotation. And the most important thing is that in LL, or we can say LL rotation, when it happens, whenever we are adding any element on left subtree to left side, left to left, then we go for LL rotation. And whenever we are adding or we are inserting any element on the right hand side, or we can say right hand side subtree to right hand side, then we will go for RR rotation. And whenever we are going for left subtree right side, then we go for LR rotation. And whenever we are going to add any element on right subtree left side, then we will go for RL rotation. Like that we can see here that this is known as left subtree, this is known as right subtree. So this is the balance tree. As we are able to see, all the balancing factor are 0, +1 and -1. So after that, if we are adding something, like suppose on right hand side, so that is known as, then we will go for RR rotation. And whenever we are adding or after adding any element on right hand side, the balancing factor will become unbalanced, like +2 or -2, then we will go for rotation, then we will go for RR rotation. And whenever we are adding anything on left subtree left side, then we will go, and after that the balancing factor is not there, or we can say the AVL tree is not balanced, then we will go for LL rotation. And in the similar way, on any left subtree right side we are adding something, then we will go for LR rotation. And if we are adding any element on right hand side left side, then we will go for RL rotation. So like that we will define that which kind of rotation it will work over here when balancing factor is not there. And one more important thing is there in LL rotation. In LL rotation, we skew the tree right side, or we can say we rotate the tree right side in LL rotation. While it is LL, still we are rotating on right hand side, opposite. In the similar way, if rotation is RR, then we skew, or we can say the rotate the AVL tree on left side, That is important. LL rotation means we skew the tree on right hand side, while RR rotation means we skew the tree on left hand side. This is right hand side, this is left hand side. How we are going to do? We will learn in the next lecture with the help of insertion example.